Hello, everyone.
Hiya.
All to the second session of Excode. So first of all, I'd like to talk about last week's feedback, which was really good. So that will be the distribution. So we're going well here. There's three main things that have changed compared to last week based on your feedback. I read those, would put notes. That's really helpful. And I think the main thing is the workshop. So this week I try to make it a little bit more clear. And also there will be three sections. So one for beginner, one for intermediate, and one for advanced. You will get the same certificate, which is a Python fluency, but it's more because I know there's a gap here and there's a huge difference of level inside of this room. You only need the beginner section to have the exam and the certificate. And the beginner section is a little bit more clear, more explained, and more structured. So try to improve it. I know the question cold code was not that clear. So this time, really, I read it through, try to make it clearer. I have also one of the workshop leaders that made diagrams for the visual learners about what is required for each workshop. So you will have that as well. Additionally, I will show at the end how to check in. Around 500 of you did check in last week, so it means that most of you understood how to do it, but I'll review it for people online and also for people that are joining us for the first time. This week, we'll talk about decoding programming, which is three main concepts. The first one is called variables. Then we will look at data types, data conversions, and finally look at programs and how to apply the things we learn to fields that you will all have in your career, such as biology or creating a website. Variables. A variable is a box inside of a computer. So if you take a box, unfortunately I have a rather small box here, but that's exactly the same. So in a box, why do we have a box for? Box is to store information. So if I take a book, like this programming book, and I put it inside of my box, the good thing about a box is that if I put it here and come back later, I'll still have my book inside of it. So I use a box to store information. A variable, it's exactly the same, but just in a computer. So it's used to store something inside of the computer, and the computer will remember it for us. I'll give you an example interaction. So I am here with my computer, and I talk, okay, please save this variable for me. But the fact is that with a physical box, I know it's here. With a computer, how can I find it? So to find it, I can put here a name. And I put a name onto my box. So now I have my box, I can find it by its name, and then I can take back what's inside. That's exactly how a variable works in a computer. So I create a variable with the equal sign. So I say, this is my variable, I have a name, and I have a value, so what you put inside the programming book or something else. Here it's hello world, the string. So say, please create that box and put inside of the box hello world and call it variable name. And then when I need it, I just go to my computer and like, what was inside of the box called variable name? And the computer is like, okay, it was hello world. And so I can get it back. And that's huge. It is so important that now we define a programming language by having a variable, meaning that something is a programming language if it is able to work and use variables. That's how important they are. Because with variables, we can take inputs from external people. We can do mathematical equations, we can do analysis, we can do plenty of things. Another core concept of variables is that they can vary, it's in the name. So here, for instance, I can create a variable, I call it variable name, and I put a value in it, but then I can update it and put a new value inside. So here I update it, then when I try to retrieve it, so ask what was inside of the box, I get the new value. Similarly, in a box, if I put a programming book, take it off and put something else, it will not store what was before. It will only give me the last thing that I've put inside of that box. Now, we look at the code. So if you go here on the Excode dashboard, if you go into week 2, you'll find the slide deck, which is this one, if you want to follow along, and also the lecture code. So if you click here, it will open the lecture code. You can follow along or just look here. I've got some feedback from people in the rear. It's a little bit unclear, so I'm going to try to zoom it in a little bit. This is the line of code. Variable name is equal to hello world to create a variable. In Python, one of the key things is that when you see the inverted commas, or also called quotes, which can be simple or double quotes, it always means it is text. So you remember last week when you did print hello world, there were the parentheses. The parentheses means that this is what we want to print, and then the inverted commas, this means that we actually have text to print. But then here, so we are assigning, so we creating that box called variable name, and inside we put hello world. So when I run this code, I click on the play button, it's doing nothing. It's simply, actually, it's not outputting something, it's simply creating that box. And I don't have any output, it's just an input. Just create a box and put hello world in it. But then when I print variable name, it is gonna print hello world. And this is the power of variables, because here what the code is doing, usually code works line by line. So your computer will read it line by line. So it reads the first line, it's like, okay, I create the box and I put hello world in it. Then it goes back like, print the name of the box. So here the computer will go back to where you created it, find back the original value and print it out. So it prints hello world. And as you can see, we have not used inverted commas here. These ones, we don't use it, because if we use those, it will not recognize it as a variable, but it will recognize it as text. So just print variable name, which is not what we want. So as I said, you can also change the value. So if I take variable name and make it equal to new text, it's changed it. So now when I print it, it's going to print new text. And I can keep doing it, basically, and it keeps updating indefinitely. I don't have a limit of how many times I can update a variable. Something that I wanted to show last week as well, when I want to do cold code, is that in Python, you can do math directly inside of statement. So if I do print 5 plus 5, it's going to print 10. That's a little bit, so I can use plus, multiplication, subtraction, and then I can create a variable and I call it number. So this is a variable. I call the name of the variable is number, and then I assign it with the equal to 5 plus 5. Then I print it, and it's going to print 10 because it does the math for us. And same thing if I want 10.5, for instance. Another important concept that you will use during this workshop as well is called string concatenation. And it's the idea when you want to print multiple things. Usually we use a plus sign to say, I want to print this plus this. So here, if I print hello plus word, what I'm saying is, please print the string, the text hello, and then print the text word together. I can also use a comma, it's the exact same thing. So you can see here and here. And I can use that also to concatenate. So concatenate means putting together. Like I have one side, I concatenate them, or multiples, and so I put them together. So that's how you can print some text with some variable. If I create a variable called my name, and I assign it to the text Lorenzo, so my name is the name of the box, it's the name of the variable. Lorenzo is the value, what I put inside of it, and then I print my name is, and then I put my name, which my name is going back to the variable, and so it's printing my name is Lorenzo. That's how, for instance, here, I have welcome Lorenzo, and everyone is welcome with their name. Here, I'm not actually writing a different web page for every single of you. It's simply a variable, which is called Excode student name. Then I put welcome, concatenate it, so add together with your name, and you all think it's personalized. That's one tool that companies use. So we can also put variables together, the same thing. So if I have a variable called hello, a variable called first variable, another variable called second variable, and they're equal to hello world, add a plus, and it puts the two together. So here I want to give you an example. So if I have a story, I'm writing a story, and this is an example I had talking with a teacher here at the university. I want to write a story, so I start in Word, which is a normal place you would write a story. And I call my two characters Bob and John. So they start and write a story. So I'll just do it normal in Word. And so I write my whole 200 pages story, short, long, about Star Wars. So it's really, there's a galaxy and there's a lot of things happening with Bob and John. And then I realized that maybe Bob and John are not the best name for characters for my era and for my beta. So what I have to do is I have to go in all my 200 Word document and change in every single way, place I call them Bob and call them John. I have to change it manually. So Bob to Luke, John to Darth Vader. So I have to change it so I have to change like 1,000 times for each. It's gonna take me days. What I can do with variables is I just create a variable called hero name, a variable called villain name, and then every time I want to put those, I put the variable and then concatenate it with a string. So then if I want to print that, I can have like Bob faces John, but if I want to change that to like Luke, I have to change it only once, and then it's gonna change it everywhere in my story. That's an example of usage of variables that you can use yourself if you are writing something and you know something will maybe change. You can use a variable, write what you need to write, assign it to a variable, and then just change it once. This can be used in plenty of ways, like changing the age of a character. And writers use it also, for example, to keep track of stories. I know there are some writers I've interacted with, and they have like, they create programming variables for every single personage, so, like keeping his age, his interaction, I don't know, his skills, his weaknesses. And then when you can use that, for instance, when he gets older, you can use it to keep track of the logic in your story. It makes the writing much more easier for you to manage because you have variables for every character. If you need to change something, you only change it once. It's going to change it in all the rest of the story. We finished the first concept, so now we can talk about data types. So similarly, in a box, we can put some things. But let's say I'm moving, so I may have a box for all my books, but then I have a box for all my kitchen stuff and a box for all my bathroom stuff. And so I need different type of box to all different things, to keep different things. And that's similar to data types. So I need different types of variables to store different information. We already saw the two mains, which are text and numbers. To make that clear, the idea is that, then we'll talk about it clearly, but the idea is that when I have different type of things I want to store, my variable, even if I create the same, will have different properties. I can add 5 plus 5, I cannot do hello plus 5, for instance. So I need to keep track of what data type, so what is in my box. Because I can take, for instance, my book and put into my kitchen box, but then if I take like, I don't know, my kitchen one and put it in my book box, it's not gonna fit. If I have another box here, but that's the concept. So the main data types are letters and words, which in programming we call characters and string. So this is more of a general name. This is the technical name in programming. So a string, it's a sequence of characters, and it can be everything. And as I said, you recognize it by the inverted commas, by the quotation marks. So hello is a string, but 17 with the quotation mark can also be a string. And a lot of errors are actually, you will see in the workshop, are actually when you try to add like 17 to like 5, but 17 is a string. So you have to check what data type it is. Characters simply like age, 7, or hashtag. So that's one of the main family of data type, which is letters, text, and it's called string in programming. Then we have numbers, and numbers in Python are divided into two main types. First type is integer, and it's whole numbers, like 5, 0, -2. And then we have float, like 2.5, -3.5. So that's the second main data type. So we got strings, numbers, so called integer or float, and then finally the third and last type is called Boolean. It's simply a logical value. You don't have to worry about that at the moment because we'll study Boolean logic later on in the course. But the idea is that it stores a logical value, so it's either true or false. This is extremely important to the logic. It's simply like only true or only false. And so if you can do, for instance, I'll give you an example. If I want to check if someone is checked in, I have a Boolean variable, which is the user checked in on my website? If that variable is false, I redirect it to the login. So I need, okay, you have to log in. If that variable is true, I have, okay, that's true, you can go to the home page and you can then interact. That's an usage of Boolean data types. So these are the three main types: string, text, it's called string, numbers called integer and float, and Boolean. We also have like a fourth category, which is a bit different, it's called nullable. So it's all the time there are errors. You will see probably some of those when you code. So null, it means that I have no value. So null is I have my box, but my box is empty. So I ask, what's inside of the box? And the computer say, oh, it's no, and there's nothing. undeclared and defined is I don't create a box, and I'm like, can you please tell me what's inside of the box? And there's no box. So that's undeclared and undefined. And not a number is when you ask for a number, but there's no number. So if like, there's my phone in my box, and I ask, can you please give me the book? And my phone, and the computer is like, there's a phone, there's no book. So for instance, not a number is an error that can arrive when you divide 0 by 0. When you say hello plus 5, it's going to say, okay, that's not a number. I cannot add 5 to hello. Code again. So here I've created some variables. So variable integer, variable float, and I can run this, and by running this, it's going to create all these variables. Then when I run print, it's going to print all of them. So 5, 3.5, hello, true, no. Just as an example, so you can see 5 is the integer and what all the types. So variable known, I set it equal to known, so it's like there's nothing in the box. But then if I say print variable undefined, I have never defined a variable undefined. So when I run this, it's going to say, error, variable undefined is not defined. You have not created the box. So if you see this error, variable undefined, it means you forgot to create a variable and you need to create it. Same thing if I try to print 0, 0, divided by 0, it's going to give an error. Or also hello plus. Any number, it's going to give an error. Because you cannot concatenate string with an integer, basically, that's the error. So you have either to put two numbers, so you're going to do a sum, or either to convert 0 to a string to then be able to print it. And here I can also print the type of these different things. So class, integer, it's going to tell me which type it is. So the first one is integer, second one is a float. This is something that we call built-in into Python. So we don't have to create it. It's already given to us by Python, like print, but type takes as an input the variable and gives as an output the type of a variable. So I can give you here, I can show that to you here. The idea here is if I do like a diagram for type is something you can use when you don't remember what data type is something. So the input it takes is a variable between parentheses, and then it will give to you as an output the variable data type. Here it is an example of abstraction. When we use type, there's someone that when he created Python, he created a code to make type work. We don't have to care because thanks to abstraction, we only care about what it does, not how it works. So now I can show you a simple program, which I think is quite useful, which is to grade personalizing someone. So here is, for instance, on a website, once you enter your name, and then it says, okay, hello, your name. That's the example I gave earlier. We can look at the code and how that will look. So this is, for instance, the input processing output. And this is how it will work. So here, what I do is I do something called a command line interaction. So I have to explain that. So when I go on the presentation, mostly on website, we have something called graphical interaction. So I can see and interact with it. I can enter manually my name. But in Colab, we do something which is command line interaction. So I directly write with Python when I take an input. And this makes it much simpler. It's not like its application usually have a visual side to it, like blocks, and you enter it in a form. But it's much simpler for the moment to do it with a command line interaction. So in Python, to do so, you have to put variable. So here is creating a variable, and you put input, what is your name? When we put input, it's like print, but it's going to print what's here inside, but as a question. So when I run this, it's going to say, ask me what is my name, and I can put like Lorenzo, and then I can run this. And now it's going to assign to create the box, and inside of the box create, add my name, Lorenzo. That's an example of how to take an input from a user. So the idea is I put input, then I put some text, which is the question, and then it's going to ask that question. It could be, what is your age? Or do you prefer red or blue? And then I can write an answer, and it's going to assign the variable to my answer. So I can do print Lorenzo. This is, for instance, what I wanted to show last week with Celsius. It's equal to input, what is the temperature in Celsius? So if I run this, it's going to ask me, like, what is the temperature? And then if I put like 10, it saves the variable Celsius with the value 10. So then I can print Celsius times 1.8 plus 32, but it gives me an error. Can someone know why it gives me an error? Can someone try to guess? Just thinking that. Yeah, that's good. Yeah. So one of the things I could do here if I find an error, and I've put it in the workshop. So I know that some of you had errors last week. So if you have a problem, oh, sorry, that's the week one. But if you have an error, I've put it into the methodology. So when if you do the workshop and you have a problem, I put a methodology tab here. So this is week one. So you can ask Google, ask a peer, ask a workshop leader, or search on Google. So we can do that together. Type error. Remember the three things to look. So where, it's here, this line, and it's a type error. So I can search that on Google. And then here I have an explanation. You can look at it. Free count cap, this one is quite good. And that's one of the way we solve errors, and that's normal. All developers do that. I can look at it, I can read this, and then I found out that the reason for this is called, as you rightfully said, is data conversion. Because when I take an input, like here, it's going to automatically create it as a string. But then when I try to multiply it in Celsius, it's going to give an error. So I say, oh, that does not work. So we can use type conversion. So I convert it from a string to an actual integers to then be able to do the math with it. So here, if I take my input processing, I take the input in Celsius, which is going to be a string automatically. Every time I take an input, it's going to be a string. Then I convert it to an integer, multiply it, add to 32, and then I can output it again. To output it, I could also, like, for instance, convert the output to a string again in order to then be able to concatenate and say, like, your temperature in Fahrenheit is now, and give that. We can look at the example in code. And so I have to do, so if I print the type of Celsius, it's going to be a string. So I have to go in code and say, so Celsius, I have it down here. So I have to say Celsius is equal to integer Celsius. So I convert it. And I put a table just down there for you to look back if you need it. So these are all the conversions. So I can, for instance, convert something to a string, to an integer, to a float, to a string, or to a boolean. This is subject to some limits. For instance, I can not convert everything to an integer, or convert everything to a float, or sometimes I have data loss. I will explain that now. So if I go here and I say, like, A is equal to 1 to 3, B is equal to int A, then I print buff type. A is going to be a string because you see there's the quotation marks, but B is going to be an integer. The output of buff is similar. Now, but now if I do A plus 5, it's going to give an error because you're adding to a string, but B plus 5 is going to work because I'm adding to an integer. And I can do that as well. So I'd have to convert Celsius to an integer. And then if I print that, it is now working because I converted Celsius, the input that I took as a string, to an integer. I converted, I changed the data type, and then I do that. It is unfortunately not always possible. This is the same saying, like, my book can fit into my kitchen box, but my kitchen things cannot fit into my book box. I'll give you some example. All integers can become strings. Like 1 to 3 can become a string, can become text. But not all strings can become integers. Like the string hello, you cannot convert it to a number, to an integer. But 1 to 3 as a string, you can convert it. Same thing with integers and floats. I can convert buff to buff, but I have a data loss in one direction. Because if I have 3.5 and convert it to an integer, which is a whole number, I'm going to lose the .5, and it's going to be either 3 or 4. So these are examples. You can look at your own if you want, but these are examples of conversions. These are called or explicit conversion because I'm actually telling the computer to change that. But sometimes I have also implicit conversion. Like here, if you look at this code, if I create a variable 1, print the type of A, it's going to be an integer. But then if I add A to 2.5, it's going to automatically convert it to a float because we're adding at 2.5 to 1, which so first before it was a whole number, and now it's a float. That's a bit an example. So I can give you an example of a conversion, implicit conversion. So when we have a Boolean, it it is also, usually we assign it to true, it's equal to 1, and false is equal to 0. So if I say I create two variables, price is equal to 50, and eStudent is equal to true. So I first run this code to create these two variables. And then when I go here, it's going to say discount is equal to eStudents times 10. What is going to happen? Please keep attention to that. That's the important bit. eStudents, if it is true, it's going to be equal to 1. If it is false, it is equal to 0. So if I want to check, so if I can, this person can have a discount, I can multiply it by 10. So if it is not a student, it's going to be 0 times 10, and so the discount is going to be 0 if student is false. But here, if student is true, so when I multiply it by 10, it's going to be 1 times 10, so the discount is going to be 10, and then I can do price, it's equal to price minus the discount, and the price is going to be 40 for student and 50 for non-students. Do you follow me? So it's either false or true. When it's false, it's 0 times 10, so no discount and full price, 50, because we're doing price equal to 50 minus 0. If it's true, it's 1 times 10 minus 10, so 50 minus 10, 40. So for instance, there are conventions in naming variables. Here we use snake case, which means we do everything in lowercase. And when there are multiple words, we use the symbol to the division. So you can check on Google when you need conventions. Declaring means when you create a variable, if you need a convention, like how should I declare a variable with 3 words? In the variable name, you can check that on Google. And usually Python has documentation, which I put also as a resource, which they tell you like how to name your variables, how to properly name the variables. As a beginner, you don't have to care a lot about that. But then if you want to go more advanced, like when you have like 50 developers working on a project, you have to care of that. And here, for instance, I can tell you an example, which I think shows you the importance of code and having right code. So it's the Ariane 5 rocket. And some of you may know that it failed. And the reason that it failed, it's quite tragic. I mean, we lost hundreds of millions in that. It's because when it actually started, they tried to convert a float to a string. And so the entire system crashed. And so the entire rocket, it's like a multi-million-dollar rocket, crashed because they tried to convert a string to a float, and they had basically the wrong data type in there. To show you how important these things are. Using variables, as I said, I will give you 3 examples and then let you go to your workshop. So the first one is sending Excode emails. So this is a general email I wrote. Then you can see the 2. This is JavaScript, it's not Python, just conceptually. So the student email is a variable. The student name is another variable, and the workshop room is another variable, and the student Excode ID is another variable. So I wrote one general email, then ran my code, and it generated, I think, 900 emails for every one of you automatically for me, and then send it automatically to all of you. For instance, here is an example in biology. It's a YouTuber called Primer, which I really like, and he uses variables and projections to study the evolution of populations. So it starts by just like showing like the birth chains, the death chains, and usually first write the mathematical equations, then put some code in there, and then you can see actually he is able to simulate really complex concepts like the maximum carrying capacity or natural selection with code and with variables and studying the evolution of variables. With Python, actually, you can do this kind of graphs, and you can generate graphs directly with Python. Python is extremely versatile and used in data analysis and to simulate environments. So now the lecture is finished. In this lecture, we saw mainly what is a variable, so a way to store information. And then we saw data types. So the types of these things can be, so either strings, numbers, integer or float, or Boolean. In the workshop, which I want to show quickly, there are 3 sections, as I said. So the section 1 is beginner. You only have to do the beginner section, which is quite short. It seems a little bit long, but you only have to do the beginner section. I recommend trying also this one as well, which is a bit of a game. If you have any question, you can look here at the methodology, so how to solve a problem, who I can talk with. For the check-in, you can all check in now. and the code is this one, EX2IQ. So you have to go on app.excode.co.uk. Please do it, because this is how you will get your certificate. Everyone, check in. So you're going to the platform. I will leave you 5 minutes. And then when you're finished, you can directly go to your workshop room. Your workshop leaders will be there waiting for you, and you can start working on the workshop. So you can check in, do it, and then go. Thank you for your time today.